Good day everyone. Today we will be talking about the measures of central tendency, being the mean, the median, and the mode. This will be our second topic under statistics. First, let us define the measures of central tendency. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. As such, measures of central tendency are sometimes called measures of central location. They are also classed as summary statistics. The mean, often called the average, is most likely the measure of central tendency that you are most familiar with. But there are others, such as the median and the mode. The mean, median, and the mode are all valid measures of central tendency. But under different conditions, some measures of central tendency become more appropriate to use than others. In the following sections, we will look at the mean, the mode, and the median, and learn how to calculate them under what conditions they are most appropriate to be used. Mean, median, and mode are three kinds of averages. There are many averages in statistics, but these are, I think, the three most common and are certainly three you are most likely to encounter in your pre-statistics courses, if the topic comes up at all. Math often deals with data sets, and data sets are often just collections or group of numbers. These numbers may be the result of a scientific measurement or surveys or other data collection methods. For example, you might record ages of each member of your family into a data set. Or you might want to measure the weight of each of your pets and list them in a data set. Those data sets are fairly small and easy to understand, and we can have a much bigger data set. A really big data set might contain the cost of every item in the store or the top speed of every land animal or the brightness of all the stars in our galaxy. Those data sets contain a lot of different numbers, and if you had to look at a big data set all at one time, it will be pretty hard to make sense of it or say much about it. That's where the mean, the median, and the mode can help us out. They are different properties of datasets that can give us useful, easy to understand information about a dataset so that we can see the big picture and understand what the data means about the world we live in. So let's learn what each property really is and find out how to calculate them for any particular dataset. Let's start with the mean or average. Mean and average are two terms for the exact same property. The mean or average is an extremely useful property. To understand what it is, let's look at a simple data set that contains 5 numbers. As visual aid, let's also represent those numbers with stacks of blocks whose heights correspond to their values: 1, 8, 3, 2, and 6. Right now, since each of the 5 numbers is different, the stacks of blocks are all different in heights. But what if we rearrange the blocks with the goal of making the stacks the same height? In other words, if each stack could have the same amount, what amount would that be? With a bit of trial and error, you'll see that we have enough blocks for each stack to have a total of 4. That means that the mean or average for our original dataset would be 4. Some of the numbers are greater than 4, and some are less. But if the amounts could all be made the same, they would all become 4. So that's the concept of the mean. It is the value that you'd get if you could smooth out or flatten all the different data values in one consistent value. It would be very inconvenient if we always had to use stacks of blocks to do it. To learn the math procedure for calculating the mean, let's start with blocks again. But this time, instead of using trial and error, let's use a more systematic way to make the stacks all the same height. This way involves a clever combination of addition and division. We know that we want to end up with 5 stacks that have the same number of blocks. So first, let's add up all of the numbers, which is like putting all of the blocks we have into one big stack. Adding up all the numbers, or counting all the blocks, shows us that we have a total of 20. Next, we divide that number stack into 5 equal parts. Since the stack has a total of 20 blocks, dividing it into 5 equal stacks means that we'll have 4 in each. So that's the math procedure you use to find the mean of a dataset. Just 2 simple steps. First, you add up all the numbers in a dataset, and then you divide the total you get by how many numbers you added up. The answer you get is the mean of the dataset. Okay, so let us use that procedure to find the mean age of the members of this fine-looking family. If we add them all up using a calculator, the total of the ages is 222 years. But then, we need to divide the total number by the number of ages we added, which is 6. 222 divided by 6 is 37. Alright, so that is the mean. So now let's go to the median. Unlike the mean, the median doesn't use the value of every data point in its calculation. The median is the middle number in a sorted list of numbers. To determine the median value in a sequence of numbers, the numbers must be first sorted or arranged in value in order from lowest to highest or highest to lowest. The median can be used to determine an approximate average or mean, but it is not to be confused with the actual mean. Median is the middle of a dataset. It's the number that splits the dataset into two equally sized groups or halves. One half contains numbers that are greater than or equal to the median. The other half contains members that are less than or equal to the median. Sometimes finding the median of a dataset is easy, and sometimes it is hard. That's because finding the value of a dataset requires that its members be in order from the least to the greatest or vice versa. And if the dataset has a lot of numbers, it might take a lot of work to put them in the right order if they are not already that way. So to make things easier, let's start with a really basic dataset that isn't in order. It's pretty easy to see that we can put this dataset in order from least to greatest just by switching the 2 and the 1. Now we have the dataset 1, 2, and 3. And finding the median or middle of this dataset is very easy. It's just 2 because 2 is located exactly in the middle. Sometimes the mean and the median of a dataset are the same number, and sometimes they are not. In the case of our simple dataset 1, 2, and 3, the median is 2 and the mean is also 2. But what about the first dataset that we found the mean of? As you can see, if we arrange the amounts or follow the procedure, we learn to calculate the mean. But what about the median? Well, the median is in the middle. And since this dataset is already in order from least to greatest, it's easy to see that the 3 is located in the middle, since it splits the other members into two equal groups. So to find the median of a set of numbers, first, you need to make sure that all the numbers are in order. And then you can identify the member that's exactly in the middle by making sure there's an equal number of members on either side of it. So what if the dataset doesn't have an obvious middle member? All the sets we've found the median of so far have an odd number of members. But what if it has an even number of members? Like the dataset 1, 2, 3, and 4. There isn't a member in the middle that splits the set into two equally sized groups. If that's the case, we can actually use what we learned about the mean to help us out. If the dataset has an even number of members, then to find the median, We need to take the two middle numbers and calculate the mean or average of those two. By doing that, we're basically figuring out what number would be exactly halfway between the two middle numbers. And that number will be our median. For example, in the set of 1, 2, 3, and 4, we need to take the middle two numbers, 2 and 3, and find the mean of those numbers. To do that, we add 2 and 3 and divide by 2. 2 plus 3 divided by 2 is equal to 2.5. So the median of the dataset is 2.5. Even though the number 2.5 isn't actually a member of the dataset, it is still the median because it represents the middle of the dataset. It splits the members into two equally sized groups. Okay, so now you know the difference between mean and median. But what about the mode of the dataset? Well, mode is just a technical word for the value in the dataset that occurs most often. The dataset we've seen so far, there hasn't even been a mode because none of the data values are ever repeated. But what if you had this dataset? This set has 6 members, but some of the values are repeated. If we rearrange them, you can see that there's 1 1, 2 2s, and 3 3s. The mode of this dataset is the value that occurs most often or most frequently. So that would be 3, since there's 3 3s. As I have mentioned, if each member in the dataset occurs only once, it has no mode. But it's possible for a dataset to have more than one mode. Here is an example of that dataset. In this dataset, the number 7 is repeated twice, but so is the number 15. That means that they tie for the title of the mode. This set has two modes, 7 and 15. Normally, the mode is used for categorical data where we wish to know which is the most common category, as illustrated below. So now that you know the mean, median, and mode of a dataset are, let's put all the new information to use on one final real-world example. Suppose there's this guy who makes and sells custom electric guitars. Here's a table showing how many guitars he sold during each month of the year. Let's find the mean, median, and the mode of this dataset. First, to find the mean, we need to add up the numbers of guitars sold each month. You could do the addition by hand or calculator if you want to. Either way, be careful, since there's a lot of numbers to add up and we don't want to make a mistake. The answer I get is 108. But to get to the mean sold each month, we need to divide the total by the number of months, which is 12. 108 divided by 12 is 9. So the mean or average is 9. Next, to find the median of the dataset, we're going to have to rearrange the 12 data points in order from smallest to largest, so we can figure out what the middle value is. Since there's an even number of members in this dataset, we can't just choose the middle number. So we're going to have to pick the two middle numbers and find the mean of them. 9 and 10 are in the middle since there's an equal number of data values on either side of them. So we need to take the mean of 9 and 10. 9 plus 10 equals 19, and then 19 divided by 2 is 9.5. So the median of the numbers of guitars sold is 9.5. That means that in half of the months, he sold more than 9.5. And in half of the month, he sold less than 9.5. Last of all, let's identify the mode of this dataset, if there's even one. There is 2 8s in the dataset, and there's 3 10s in the dataset. That looks like the most frequent number. So 10 is the mode of this dataset. It is the result that occurred most often. Alright, so that's the basics of mean, median, and the mode. They are 3 really useful properties of the dataset, and now you know how to find them. So remember, mean means average, and median is in the middle, And mode starts with M and O, which can remind you that it's the number that occurs most often. Okay, everyone, that ends our discussion on central tendencies, and I hope you have learned something. Thank you so much for watching and be safe.